This video is going to talk about random variables, which is section 3.4 in the textbook. A random variable is a numeric quantity whose value depends on the outcome of a random event. We use a capital letter like capital X to denote a random variable, and the values that the random variable takes are denoted with a lowercase letter. In this case, we'd use little x. So we'd talk about the probability that the random variable x takes on the value little x. So we might be interested in something like, we could let x equal the number of heads in 2 coin flips. And I could think about figuring out what the probability is that the number of heads, x, is equal to 0. And since I've got independent events and each one should be equally likely to land heads up, the chance of having the first one land with heads down would be 1/2. Second one landing with heads down and tails up would be 1/2. I'd have to have that happen in both flips to have no heads. And so I can think about calculating the probability that there are no heads in 2 coin flips as 1/4. So just getting used to the idea that the capital X is talking about the random variable, the number of heads that will occur in 2 coin flips. The value little x would correspond to a particular value that I might want to find the probability of that value of the random variable occurring. Now there are 2 main types of random variables. Discrete random variables are ones that take only integer values. For example, we might have the number of credit hours that a person is taking, or the number of siblings that a person has. Those would be discrete random variables. Continuous random variables take real number or decimal values. For example, the time it takes to run a mile or the weight of an apple. So generally speaking, as we're thinking about these 2 types of variables, discrete random variables are things that we count, and continuous random variables are things that we measure generally. When we talk about expectation or the expected value, we're often interested in the average outcome of a random variable. For instance, if I flip 2 coins, what's the average number of heads that I'd expect to land facing up? And we call this average the expected value or the mean. It's just calculated by finding a weighted average of the possible values, where the weights are determined by the probability of each of those values. So we use the notation mu to indicate that this is the mean or the expected value. E of x means the expected value of the random variable x. And we calculate it by taking each of the possible values, x sub I, multiplying it by its probability, and then adding those all up for all the different possible values of the random variable. Let's look at an example of calculating the expected value for a discrete random variable. In a game of cards, you win $1 if you draw a heart, $5 if you draw an ace including the ace of hearts, $10 if you draw the king of spades, and nothing for any other card you draw. We're going to write the probability model for your winnings and calculate your expected winning. Okay, so in this situation, our random variable that we're interested in, capital X, is the winning. And to write the probability model, we're going to list all of the possible values, little x, for the winnings. and figure out the probability that the winnings takes on each of those values. So we know right away that we can win $1, $5, $10, or nothing. Now the $10 is only if you draw the king of spades. Since there are 52 cards in a deck and only one of them is the king of spades, the probability of winning $10 is 1 out of 52. We also know that you get $5 if you draw an ace, including the ace of hearts. There are 4 aces out of 52 cards, so the probability of winning $5 is 4 out of 52. And $1 if you draw a heart, but remember you're getting $5 if you get the ace of hearts, so there are 12 other hearts in the deck out of 52 cards, so the chance of winning $1 are 12 out of 52. And then there are 35 remaining cards for which we don't win anything, so the probability of winning nothing is 0 out of 52. So remember, when we want to calculate the expected winning, so the mean of the winnings, or the expected value, E, of our random variable x, the winnings, we're going to do it by taking each of the possible values of x and multiplying by the probability that it takes on that value, and then adding them all up. So I'm going to add another column here, where I'm going to multiply x times the probability that the random variable big X takes on that value. So here I'll have 1 times 12 out of 52. Here I'll have 5 times 4 out of 52. Here I'll have 10 times 1 out of 52. And here I have 0 times 35 over 52. If I add those all up, it gives me 42 over 52. And so my mean, or my expected value of x, is 42 over 52, which is approximately equal to 0.81. So my expected earnings is approximately 81 cents. Now I can graphically represent the probability of distribution of winnings from this game. Here I have my values, little x, of the winnings. And here I have the probability that the winnings takes on each of those values, displayed on the vertical. And remember, the expected value was about 0.81, so between 0 and 1 was my expected value of x, 81 cents. Now I can also think about, remember, we've got something here, the winnings is numerical. You can see we've got a distribution that's kind of skewed. We've thought about what a typical value, or the center or the mean of this distribution would be. I can also think about how much variability there is in the outcomes of this discrete random variable. And so when we want to measure that, we use the variance, or the standard deviation, of the random variable. To calculate the variance of the random variable, we take the deviation between each value, x sub I, and the mean of the random variable. We square those deviations, multiply them by the probability that the random variable takes on that value, and add them up. And then if we want to take the standard deviation, remember, just as with a normal data set, the standard deviation is just the square root of the variance. So again, coming to this previous card game, we can talk about the expected winnings and how we'd expect them to vary. Remember that we had our probability distribution that we found and the expected value that we found previously. Now, when we want to find the variance, remember we're going to, for each value, subtract off the expected value of x, find the deviation between that value and the mean, square that, and then multiply by the probability that x takes on that value. So over here, you can kind of think about what that looks like. So I can take x minus the mean of x, 42 over 52, be squaring that and multiplying by the probability that x equals x. So here I have 1 minus 42 over 52 squared times 12 over 52. Here I have my value of x is 5. 5 minus the mean of x, 42 over 52, squared times the probability that x equals 5, 4 out of 52. X is 10 here, minus the mean, 42 over 52, squared times 1 over 52. And here I have 0 minus 42 over 52 squared times 35 over 52. And again, to find the variance, I'm going to just add those all up. In total, that gives me approximately 3.42. And remember, I can use my notation sigma squared for that variance. And if I want to find the standard deviation, is going to be the square root of 3.42, which is approximately 1.85. So typically I expect my winnings to be about 81 cents and vary from that by about by about $1.85. Sometimes we are interested in linear combinations of random variables. A linear combination of two random variables, x and y, is a function of the form a times x plus b times y, where a and b are just some fixed numbers, some constant values. The average value or the expected value of a linear combination of random variables is given by this formula. The expected value of a times x plus b times y is equal to a times the expected value of x plus b times the expected value of y. We can use the definition of the expected value to factor out the a's and b's to prove this if we like. So we'll do an example calculating the expectation of a linear combination. On average, a bag of apples contains 8 apples and a bag of oranges contains 6 oranges. As a fundraiser, a club is planning to sell fruit at a picnic. They will sell apples for $1 each and oranges for $2 each. If the club buys 1 bag of apples and 1 bag of oranges and sells all of the fruit, what is the expected amount of money collected from the sale of the fruit? Okay, so here, first of all, I'm going to let x equal the number of apples in the bag. And we know the average, the expected value of the number of apples in the bag is 8. And I'm going to let y equal the number of oranges in the bag. And the expected value of y, we're told, is 6. Okay, so we're starting from there. Now they're selling the apples for $1 each. So the amount of money, sales money, is going to be $1 times the number of apples in the bag, plus we're going to sell the oranges for $2 each, $2 times the number of oranges in the bag. So now I want to find the expected value of this. So the expected value of 1 times x plus 2 times y is going to be equal to 1 times the expected value of x plus 2 times the expected value of y, which is 1 times 8, because we expect 8 apples per bag, plus 2 times 6, we expect 6 oranges per bag, sorry. So 12 and 8 is 20. So the expected sales would be $20. Now we can also measure the variability of a linear combination of two independent random variables. To do so, we find that the variance of a times x plus b times y is a squared times the variance of x plus b squared times the variance of y. And remember that the standard deviation of the linear combination would just be the square root of that variance. And I'll just mention that this formula is only correct if the variables are independent. If they're not independent, then there's a more complicated formula that we need to use, and that's outside the scope of what we're going to do in this course. So coming back to our same example, we're adding a little bit more information. Remember that on average a bag of apples contains 8 apples. Now we're told that the standard deviation for the number of apples in the bag is 1.5. So there's our standard deviation for the apples. So sigma of x is 1.5. The bag of oranges, which is the number of oranges we said was y, on average contains 6 oranges. Standard deviation of that is 0.75. So sigma, our standard deviation for the number of oranges in a bag, is 0.75. At the fundraiser, remember, they are selling apples for $1 each and oranges for $2 each. So again, as we saw before, we're trying to find the variance now instead of the expected value. We're finding the expected variance of, 1 times x, the number of apples in the bag, plus 2 times y, the number of oranges in the bag of oranges. Okay, so the linear combination formula tells us this variance is equal to the constant 1 squared times the variance of x plus the constant we're multiplying by y, 2 squared times the variance of y, which is equal to 1 squared times the variance of x. Now we're given the standard deviation of x, so the variance, sigma squared of x, is equal to 1.5 squared and we have 2 squared times the variance of y. We're given the standard deviation of y, so the variance, sigma squared of y, is going to be 0.75 squared. We do our calculations. This will give us a variance of $4.5 squared. Remember, when we are looking at variance, because we've squared everything, we get these squared units, which is strange. And so if we want to find the standard deviation, which will bring us back to our original units of dollars of this amount of money we generate, it's going to be the square root of the variance, which is approximately equal to $2.12. One thing to be cautious about is just remembering that random variables don't work like normal algebraic variables. If I have two random iterations of an experiment that produce an outcome x and I add them together, then x plus x is not the same as having 2 times x. Let me explain why. If I think about sort of x plus x, this is adding together two separate random quantities. Whereas multiplying 2 times x is taking a single random quantity multiplying it by 2. So this would be like, for instance, the difference between I roll a 6-sided dice twice and I add up the sum of the two numbers that come landing facing up, versus the second one would be 2 times x would be I roll the die once and I multiply the outcome for the number that's landing face up by 2. We can understand that those are very different things that would have different probability distributions associated with them. And just to kind of note, if I find the expected value of x plus x, well, that's the expected value of x plus the expected value of x, which is 2 times the expected value of x, and the expected value of 2x is 2 times the expected value of x. So the expected value will be the same either way. But what's different is the variance. And remember, if we assume that we've got independence between these two random quantities, x and x, right, then our variance of their sum is going to be the sum of their variances. So variance of x plus variance of x is 2 times the variance of x. On the other hand, if I take the variance of 2 times a single random quantity x, the variance of that is 2 squared times the variance of x, which is 4 times the variance of x. So it's really important to think carefully as we're looking at these kinds of linear combination type problems to think about whether we are adding together multiple random quantities or taking a single random quantity and multiplying it by a constant. So it's really important, as I say, to think about whether we're adding together separate random quantities or multiplying a single random quantity by some constant. So for example, here we have an example where a company has 4 Lincoln Town Cars in its fleet. Historical data show that the annual maintenance cost for each car, we'll call that annual maintenance cost, will be our random variable x, is on average $2,154 with a standard deviation of $132. And we want to know what is the mean and the standard deviation of the total maintenance cost for this fleet. So the maintenance cost for each car is random, and it's probably going to be different for each car. So instead of having a single random quantity, we have 5 different random quantities. So we should note we've got 5 cars, each with given maintenance cost. And we can denote those x sub 1 through x sub 5 to distinguish between the cars. And we're adding those different maintenance costs together. It's not the situation where we have just one annual maintenance cost that's common for all the cars and we're multiplying it by 5. So this is a situation where we should be using adding rather than multiplying. What this means is that when we find the expected value of this sum, it's the sum of the expected values. And since these are all the same, that gives us 5 times the expected value of the maintenance cost for a single car. And that gives us a total expected maintenance cost of $10,770. Note that when we want to find the variance of this sum, we then take the sum of the variances, which gives us 5 times the variance in a single car. Since I was given the standard deviation of 132, I have to square that to get the variance for an individual car cost. And that gives me a variance of $87,120 squared, right? And that's in, I guess, squared dollars. And so the standard deviation would be the square root of that, which gives us a standard deviation of $295.16. I hope you found this video helpful. Have a good day.